All right, kiddos, today we're going to look at solving systems of equations using a graphing method. So, for example, let's say that we've got these two fun equations of 2x plus y equals 3 and 6x equals 9 minus 3y. If we're going to solve by graphing, remember that we have to get each of these in y equals form. So, I'm going to take this one. I've got 2x plus y equals 3. Let's get y by itself, so I'm going to subtract 2x from both sides. So I've got y equals, remember, since 3 is a number and negative 2x has a variable, we cannot combine those two. So we've got negative 2x plus 3. So there's one equation. All right? Now let's take the other one. Let's go ahead and get y by itself. Let's subtract the 9. So we've got 6x minus 9 equals negative 3y. Now we still have to get y by itself. So to get y by itself, since it's negative 3 times y, we actually have to divide by negative 3. If we divide one side, we have to divide the whole entire side by the other. So it's divide by negative 3 below the 6x and divide by negative 3 over the 9. So now we're going to simplify. Negative 3 divided by negative 3 is just y. Negative 6 divided by negative 3 is negative 2x. All right, and negative 9 divided by negative 3 is positive 3. So now we got these first two equations. So we got them in y equals form, so to find the solution, now we simply need to graph them. So let's get some graph paper. I know you guys love graphing so much. Certainly move this over here so we can see that. So we can type this in our calculator, or we can actually remember how to graph. So if we're looking here, we got 3 as our y-intercept. So we go up 1, 2, 3. And then our slope is negative 2, so that means we're going to go down 2 over 1. So down 2, 1, 2 over 1. Down 2, 1, 2 over 1. Down 2 over 1. When I get enough points, I usually try to get 3. Then I can connect them with a line. So there we go. Now my points are connected. Get that a little bit straighter for you, because if not, I know you guys are going to point that out later when you see me. So we got that. I know my line doesn't have arrows at the end, but forgive me right now. We'll just fix that. Okay. And now we're going to do our other equation. We're going to graph this one over here. So again, our y-intercept is 3. So we're going to go up 1, 2, 3. Uh-oh, what's happening? Okay, they're sharing a point right now, but we got a slip of negative 2, which means we're going to go down 2 over 1, down 2, 1, 2 over 1, down 2 over 1. What? Oh my gosh, what do you notice? What is the same about these two lines? I'm going to graph it in green so you can kind of see over that's the same line. Since this equation here and this equation here are the same lines, and in the picture, it's a line on top of a line, the answer is going to be so we have infinitely many solutions. Okay? That's if it's the same line. All right. Let's do another example where you actually get a solution, but I wanted to go ahead and show you that so that if you ever get the equations, when you manipulate the equations and they turn out to be the same line, you don't even have to graph it. You can just you can automatically tell me that it's infinitely many solutions. All right, on to our next example. Let's find a fun one that gives you like some nice pretty numbers. I won't give you some decimals yet. I'll catch you a break. So let's say we've got 3y plus 6x equals 3. And then we've got another equation of x minus y equals negative 7. Again, to graph any equation, they have to be in y equals form. So let's take this one. We've got 3y plus 6x equals 3. Let's get y by ourselves. So let's leave that there. Let's leave that. And so we'll do, since it's plus 6x, we'll do minus 6x. Minus 6x. So we've got 3y equals negative 6x plus 3. Again, I've got 3 times y, so to undo multiplication, I have to divide. If I divide once, I have to divide every other little piece by that. So I've got y equals negative 6 divided by 3 is negative 2. 3 divided by 3 is, so let me make that a little prettier for you. Negative 6 divided by negative 3 is, by positive 3 is negative 2x. 3 divided by 3 is plus 1. So I've got this guy here. Now I'm going to take my other one. Again, I got to get y by itself. See how y is negative? That kind of poses a problem. I can leave it or I can move it. It's really going to be up to you. But if I leave that and I move the x, since the x is positive, I've got negative y equals negative x minus 7. If I need to get this positive, see how it's really, there's multiplying by negative 1 right there? I really am going to have to divide by negative 1. And what that does is it's really just going to change all the signs. So a negative is positive. A negative is positive. And a negative is positive. So there's my equation. So now that I've got my 2 equations into y equals form, I'm going to grab a graph. Let me see if I can get this out of the way. Oh, I lost my y. There we go. So I'll go ahead and graph the blue one in blue. So y plus 7. 7 is my y-intercept. 1, 2, 3, 4, 5, 6, 7. Since my slope right here is 1x, that means I'm going to go up 1 and over 1. So up 1 over 1, up 1 over 1. I'm going to go ahead and connect those nice little lines. I'll even make it match blue color. All right. It doesn't want to let me, it doesn't want to be nice. There we go. And actually that shouldn't be dotted at all. It should be solid. Let me fix that because later you'll learn about dashed lines and I really don't want you to get confused. There we go. All right. So there's my nice pretty blue line connecting the blue point. So now I'm going to take my pink. I've got negative 2x plus 1. 1 is my y-intercept, so I'm going to go up 1 on the y-axis. My slope is negative 2, so I'm going to go, since it's negative, I'm going to go down 2, but then I'm going to go over 1, and this over direction to the right is actually positive, so it's like saying negative 2 over positive 1. So I'm going to go down 2 over 1. So down 1, 2, over 1, down 1, 2, over 1, down 1, 2, over 1, 1, 2, over 1. So there. So now we've got the other piece of our line. Let's go ahead. We'll make that pink just so we can match and tell the difference. It might be a red, but you guys will be all right. All right. So let's go ahead and connect that. Okay, came out red. All right, so what we want to see now is we want to look for the point of intersection. The point of intersection is actually going to be our solution. So if we look right there, do you see that? Right there, okay? This area right there, where they cross, that is going to be your solution. Okay, so that's what we're looking for. Wait, oh, there's the X button. Okay, so that's my solution. So I'm looking for that point right there. It is 1, 2. I went negative 2. Now I'm going to go up 1, 2, 3, 4, 5. And then I went up 5, so it's positive. So this right here is my solution, which is basically means x equals negative 2 and y equals 5. And we write it as a coordinate point. We write it as a coordinate point because if you recall from your algebra skills that the first letter written is always y and the second one is, the first letter written is always x and the second one is always y. So there we've got a fun example of how to solve a systems of equations using 2 variables, and then we also have one where it showed infinitely many. Okay, one more example just so you have the information. We're also going to have some equations that yield us no solution. All right, and that's going to be when the 2 lines are parallel. Okay, an example of that's going to be if two lines are parallel, that means that they have the same slope. So if they have the same slope and they're parallel, that means they're never, ever, ever going to intersect. So if they never intersect, they never have a solution. And an example here would be if we had y equals negative 3x plus 3 and y equals negative 3x minus 2. Notice that they have the same slope. Right here we've got negative 3 and we've got negative 3, but they're not the same line because they have different y-intercepts. So since they have different y-intercepts, they're going to be parallel. So I'm going to graph those real quick for you to see, and then you'll have a nice pretty example of what that's going to be. Okay, let's grab a graph. I've got that. Again, we'll go with this one first. Since I'm plus 3, my y-intercept is 3, I'm going to go up 1, 2, 3. I've got a slope of negative 3, which since I'm negative means I'm going to go down 3 and positive 1. So 1, 2, 3 over 1. 1, 2, 3 over 1. 1, 2, 3 over 1. I'm going to connect my dots. Got a nice pretty line going on there. Since it's equals, I need to make sure that it's not dashed. It's actually going to be solid. There we go. That's better. And then in blue, we have a y-intercept of negative 2. But we have the same slope of negative 3, which means we go down 3 and positive 1. So 1, 2, 3 over 1. 1, 2, 3 over 1. Again, connect a nice little pretty line. Let's make it blue so it matches the color of ink so you don't get confused. And let me line that up and make it pretty for you. I know my drawing is not perfect, but if you look at it, they're both increasing. Actually, they're both decreasing because they have negative slopes. And there's no point of intersection. Since there's no point of intersection, they are going to be no solution as your answer. So I hope this clarifies graphing systems of equations.